Next one is called as transmission modes. Transmission mode explains when we have to send some data, whether we are sending the data in bit by bit, or we are grouping the bits and sending that group at a time. That is explained by actually transmission modes. There are two types of transmission modes are there. The first one is called as parallel mode, in which you can group a number of bits and send each group at a time. Sending data bit by bit, that is one bit at a time. Okay, at one clock tick, one bit will be sent. Here at one clock tick, we are sending a group of bits. In serial mode, there are three types of technique is there. One is called as asynchronous. The first one is called as parallel transmission. In time, sender as well as receiver are dealing with n number of bits. Here n number of bits are sending, here n number of bits are receiving at the same time. This is called as parallel transmission. This type of transmission generally happens in your local computer most of the times. In serial transmission, instead of a group of bits, we are transmitting a bit by bit, or we are grouping the bits and sending that group at a time. That is explained by actually transmission modes. There are two types of transmission modes are there. You can group a number of bits and send each group at a time. In serial mode, we are sending data bit by bit, that is one bit at a time. Okay, at one clock tick, one bit will be sent. Here at one clock tick, we are sending a group of bits. In serial so isochronous. These are the different transmission modes. The first one is called as parallel transmission. In parallel transmission, we are grouping ones and zeros into a group. N number of bits are we are grouping here and transmit that n number of bits at the same time. Sender as well as receiver are dealing with n number of bits. Here n number of bits are sending, here n number of bits are receiving at the same time. This is called as parallel transmission. This type of transmission is generally happens in your local computer most of the times. And serial transmission. The second one is called as serial transmission. In serial transmission, instead of a group of bits, we are transmitting a bit only one. Next one is called as transmission modes. Transmission mode explains when we have to send some data, whether we are sending the data in bit by bit or we are grouping the bits and sending that group at a time. That is explained by the transmission modes. There are two types of transmission modes are there. The first one is called as parallel mode, in which you can send each group at a time. In serial mode, we are sending data bit by bit, that is one bit at a time. Okay, at one clock tick, one bit will be sent. Here at one clock tick, we are sending a group of bits. In serial mode, there are three types of technique is there. One is called as asynchronous, second one is synchronous, and last one is called as isochronous. These are the different transmission modes. The first one is called as parallel transmission. In parallel transmission, we are grouping ones and zeros into a group. N number of bits are we are grouping here and transmit that n number of bits at the same time. Sender as well as receiver are dealing with n number of bits. Here n number of bits are sending, here n number of bits are receiving at the same time. This is called as parallel transmission. This type of transmission is generally happens in your local computer most of the times. And serial transmission is called as serial transmission. In serial transmission, instead of a group of bits, we are transmitting a bit by bit. On single clock tick, we are sending one bit at a time. Only one communication line. Here what happens in parallel, for sending n number of bits, we need n number of separate lines are there, separate cables or lines are there. But here in serial transmission, we are transmitting the entire data one by one using a single line. N number of bits are transmitted one by one in a single line. So what is the advantage? It will reduce the cost of transmission. Instead of n separate wires, we are using a single wire, so reduce the cost of the transmission. The next one is called as asynchronous transmission. Asynchronous transmission. In asynchronous transmission, the timing of signal is unimportant. Here, the receiver actually retrieves the information bit by bit and translated into a proper data by using some agreed pattern. Here, both the sender and the receivers are maintaining some type of pattern. Based on that pattern, it will collect the data. As long as this pattern will be followed by this receiver, the receiver can accept data without any rhythm between sender and receiver. What is the meaning here? There is no need of any clock set between these two devices. The sender continuously sending the data. The receiver is actually receive the data whenever it got the data. How actually the patterns is created? The sender actually groups the bit stream into bytes. Each group is actually 8 bits and send along with the line. The sending system and each group independently, relaying it to the link whenever it is ready. What the sender will do, whenever the medium is free, it will send one bit stream to the receiver without any timer setting. The receiver has to identify the arrival of this bit stream. So one alert bit is sent at the beginning of the packet, that is 0. Whenever the 0 occurs, receiver understood that some packets are, some bit streams are coming. At the same time, an extra bit called as 1 or some additional bits are added at the end. That is called as stop bits. Here the first bit is called as start bit. Whenever the start bit is identified with the receiver, it reads one by one. Whenever stop reading and waiting for the next stream. Once the entire stream is read by the receiver, a gap will be provided by the sender. Here the gap will indicate there may be a next stream available. The gap will be generated by delayed with signal or by adding extra ending bits or stop bits. This mechanism is called asynchronous because at the byte level, the sender and the receiver do not have to be synchronized. That means there is no clock set between sender and receiver. Just send the data. Whenever the receiver finds that there the data, it can just receive it. But at the receiver end, the synchronization will be done. Whenever it finds the first bit, start bit, it sets a one timer. It sets one timer. It is converted into a data. And just wait for the next stream. The next one is called as synchronous transmission. In synchronous transmissions, the stream is combined. You see here, it's a combination of multiple bytes. It's a combine multiple bytes and create a frame and send bit by bit transmission. In synchronous, the next one is called as synchronous transmission. In synchronous transmissions, the stream is combined into a longer frames which may contain multiple bytes. You see here, it's a combination of multiple bytes It's a combine multiple bytes and create a frame and send bit by bit. Each byte, however, is introduced onto the transmission link without a gap between them. If you see properly, in within one frame, number of bytes are there, but there is no gap between them. If in diagram there is a one line is given here, that means there is no in actually there is no gap. It's a bit stream, entire bit. It is to the receiver. The next one is called as synchronous transmission. In synchronous transmissions, contain multiple bytes. You see here, it's a combination of multiple bytes. It's a combine multiple bytes and create a frame and send bit by bit. Each byte, however, is introduced onto the transmission link without a gap between them. If we see properly, in within one frame, number of bytes are there, but there is no gap between them. If in diagram there is a one line is given here, that means there is no in actually there is no gap. It's a bit stream, entire bit stream. It is left to the receiver to separate the bit stream into bytes. What the receiver will do, it will collect one frame and convert that into 88 bytes. One of the important points you have to remember is there is no any starting bit here and there is no any ending bit. In a synchronous transmission, it is the job of the receiver to convert the stream bits into byte or character. In a synchronous transmission, we send a bit one after another. And if the sender wants to send more frames, he can provide a gap between them by applying a special sequence of zeros and ones. Here he is adding some special zeros and ones which indicates a ideal situation. The receiver counts the number of bits and group them into a 8-bit or characters. The next serial transmission mode is called as isochronous transmission mode. In some real life applications where we have to transmit the data in the form of audio or video, the delay between the frames are very important, which can be which can be not possible using some synchronous transmission method. Even the synchronous transmission method is faster. You cannot get the real time speed with the synchronous transmission method. For that one, we are using one more technique called as isochronous transmission technique. For example, in TV images, it is broadcast 30 images per second. All the 30 images should be viewed at the same time. So the delivering of frame should be at the same rate. If each image is sent by one or more number of frames, there should be not delay between the frames. If there is a frame delay occurs, there should be a flickering effect may be shown in your TV. For this type of application, a synchronization between character is not enough. The entire stream of bits must be synchronized. This can be done by isochronous transmission, and this transmission guarantees that the data arrives at a fixed rate. And today, where the most speed is important, really in audio and video applications, where data may be corrupted, but frame rate is important. In that situations, isochronous transmission is used.